But we do have some questions from the web, and I just want to read them and we can introduce them into our discussion. These are clarifying questions, I believe. From Thomas Didek. In Dr. Lange's graphs, the variability in FEV response for those inhaling filtered air only, should these control, and that's controls in quotes, should these control responses be subtracted from the, in quotes, exposed responses to show the actual effect of exposure? So, Dr. Lange, I think that's a clarifying question to you.
Yep. So that's been done both ways. Some groups have done it where they subtracted it, some haven't. We didn't because we wanted to see the variability that just exposure to filtered air would cause, and it's pretty considerable, that the variability just in responses. The other thing that we were concerned about is that on an individual basis, if you expose somebody to filtered air and you expose them to ozone, the FEV1 responses don't correlate with one another, which suggests that there are different mechanisms involved. And I worry that we will obscure something, or that we're not accurately subtracting like from like when we subtract the filtered air response from the ozone response.
Okay, so I'm going to do a follow-up on this question. So what you're saying is the responses you showed were from the pre-exposure FEV1s to the exposed FEV1s.
They were from the baseline from the day of. The other, sorry, I just thought of, so the ones that we've shown are the at the end of an experiment, the FEV1 that was measured versus at the beginning of the experiment before a person was exposed to ozone on the same day. Now, individual variability can change too, and because filtered air exposures are done on different days, they could be weeks or months away from the ozone exposure, you can run into just a natural variability that can also be not accurate in terms of subtracting it from the response.
Okay, so I want to make sure, the graphs that you showed were changes from that day's exposed control, that day's control.
That day's control, that's correct.
Okay, here's another question from also Thomas Didek. What about indoor-outdoor relationships for ozone? How should that be considered, if at all? I mean, this is to maybe not only yourself, Dr. Lange, but any of the science panel members.
I guess I'll start and then maybe we can go around.
Sure.
So for my exposures, I'm assuming that a person is outdoors during their exposure because the concentrations that I'm talking about are ambient, outdoor measured concentrations. The indoor concentrations, we don't have numbers for those. Typically, they're not measured unless they're done on very particular studies, and then they're variable depending on whether or not you open a window or how much air conditioning or what time of year it is. So it is very relevant that the indoor levels are much lower. What those numbers are, we can't say as accurately as the ambient numbers. They're not even necessarily correlated between the indoor numbers and the outdoor numbers.
Any additions to that? Go ahead, Dr. Utell.
That's correct. I mean, the indoor levels are quite low. There are some measurements that have been done in homes and buildings and so on. I don't actually recall the numbers, but your ozone exposure is primarily an outdoor exposure. It's very unlikely, unless you happen to have an ozone generator in your home. And there are some folks who have, for different reasons, have had ozone generators. There have been some fairly high levels in those settings, but in the general indoor environment, there's very little ozone.
Okay. Yes.
Just to clarify on that, the typical numbers are 10, 20%, maybe as high as 30% if the windows are open of outdoor. Is what you'll see indoor. But there's some other stuff that goes along with that I'll talk about tomorrow a little bit.
Okay. Hopefully that answered the question. I have another question. This is from Steve Packham. And Mr. Packham is from the Utah Department of Environmental Quality. This question is sort of ozone by the numbers. I'm going to read you a series of numbers that has to do with mode of action. 1 hour exposure to 75 micrograms per meter cube of ozone is 300 micrograms of ozone. And if you do Avogadro's numbers, you get about 5 times 10 to the 12th molecules of ozone. Okay? That's the first set of numbers. Type 2 cells secrete antioxidants. A whole bunch of 67 type 2 cells per 200 micrometers squared is 2 times 10 to the 10th type 2 cells. Second number. You divide the two, each type 2 cell needs to neutralize 250 ozone molecules. So now that we have these numbers quantified, I mean, there's citations for each of these. Here's the question. Can one type 2 cell secrete enough antioxidants to neutralize 250 molecules of ozone? And can you use that as a basis of a threshold? Per hour. Any thoughts?
We could look at that. I mean, I like going by the numbers, as you've seen. I would say that we would have to make sure that we have precise enough numbers of what the antioxidants are in our lavage, because we get them from nasal lavages and from bronchoalveolar lavages. So we would have to have a certain amount of confidence in how much antioxidants we actually have in those respiratory tract lining fluids, but I think it would be interesting to do. I want to point out, so at the beginning of that question, he said 75 micrograms per meter cubed.
Right.
That's parts per billion. Okay,
Yeah.
just wanted to check because it's
Pardon me.
38. Yeah, okay. Just,
Okay.
yeah.
Yeah, a comment. To model that, you need to know the type 2 cells are in the deep lung, and they comprise, what is it, 5 or 10% of the surface area of the alveolus? So the type 1 cells are really the target. But if you just left it to type 2 cells, you'd have to calculate the fraction of ozone molecules that got to the alveolus,
Mm-hmm.
and then say if it deposited evenly, the fraction that got to the type 2 cells. And so my guess is, yeah, they could handle it.
Yeah, so the answer is we could take this kind of information and
Model.
think about mode of action from a very physiological perspective. I mean, here's.
But I think I'd look at the type 1 cell instead.
Sure. Okay. And Mr. Packman's in the audience, so
Yes.
we can talk to him further about that. Okay, we do have another question, but it's a little bit more appropriate for later on. So why don't we hold that question, and we'll go out now to other clarifying questions to Dr. Lange's presentation from our panel. Any other clarifying questions before we get into discussion? Okay. First discussion question is, again, this is in your packets and it's on the website. Under controlled exposure studies, how do we relate exposure conditions and adverse outcomes in controlled exposure studies to the general population, including sensitive individuals or subgroups? So anybody want to take a crack at that on the science panel? How do we relate exposure conditions and adverse outcomes in the controlled exposure studies to the general population, including sensitive, well, it says individuals, but subgroups is more relevant.
I think we've kind of talked about this, the exposures in the chamber, what we consider or don't consider an adverse outcome, and then the sensitive individual, I think, would be largely the asthmatic subpopulation. I don't know if there's a specific question that's driving this, but I without that, I don't have much more to add than what we've talked about.
Well, from Dr. Lange's multiple graphs, some of which included
Oh, okay.
supposedly sensitive subgroups. They didn't look like there were that many changes, but maybe they're not the right sensitive subgroup, I don't know. Does that help to relate those exposure conditions and adverse outcomes?
Well, I mean, the finding is quite interesting in that it looks like the severity of the response, if you like, seems to be ameliorated with time. So the short-term exposure has a larger decrement across the board than the 6.5 hour exposure. It's important, I think, in terms of understanding. I don't know if it's helpful in relating it to the general population, but it might suggest that, you know, the 1 hour exposure or the 2 hour exposure is going to have a greater decrement. But if you continue, if you're outdoors working and someone asks for 8 hours, that in fact, it doesn't continue at that, to that degree of loss of volume. And whether it's replenishment of the antioxidants or whatever the mechanism, it just suggests that the intensity of the effect may not be that great. One of the things we don't know, and I think Dr. Lange said she hadn't looked at it yet, is in those 6.5 hours, do we know what the response was at 2 or 3 hours? Was it just like the short term, or in fact, is there some evidence for whatever reason that you're not seeing as profound a decrement in those longer studies? And that would be important to understand.
I did that.
You
Okay.
did look at it,
Yes,
okay.
yeah, because you mentioned it at the pre-workshop webinar.
But before we get to there, I want to make sure what you showed us was pre-exposure and after 8 hour exposure, right?
Right.
Right.
So that's what the graphs we saw. So now you said you've done some other graphs.
Right, so the difference,
Okay.
what Dr. Utell is talking about is that in those really the 6.6 hour
hours.
exposures, they took intermediate time points, so they looked at them at after every hour. So in theory, if you have a heightened response in the early hours compared to the later hours, which is what the graphs that I showed you were suggesting, then you would expect that the early time points for those exposures would have a more severe effect than the later time points. And so this isn't something that we've included in the main analysis because I have to do graph estimation. I don't have actual numbers for that. You have to estimate it from the graphs that were provided in the papers. So those are the data that I have. But effectively, what you can see is that there are two different. Even if you divide up the data between less than 3 hours and then 5 to 6 hours, you do have a more severe dose response than in the less than 3 hours as you do in the 5 to 6 hours
Now,
within the same experiment.
so,
Right.
So it's consistent.
so Dr. Lange, are those in experiments where you had a varying exposure or a steady exposure?
Either,
So that, it seems to me that would.
if you
it-
calculate dose.
Well, okay, so what we're talking about is you're doing, the graphs that you showed were not concentration, they were,
Dose.
as you say, dose. It's concentration times ventilation times time.
Right.
We're gonna take these and pass them out?
Yep.
We are. Okay, we are.
So just so I understood, in the longer studies, you found the same greater intensity in the response in the first 3 hours?
Yes.
Okay.
And we
Okay,
can
so what
post
did you
this
just,
on the-
okay, we passed out something in, how are we gonna make this available to everybody else? What is this, Dr. Lange?
Yes, he's gonna talk from it, and we'll post it on the website.
Okay.
Oh, good.
As you send it to me.
Yeah, so I will send this to you. I'll describe it. So what we're looking at, and what hopefully they will be looking at soon, is a division of the data points within a single set of studies. So these are the intermediate time points. We don't usually include the intermediate time points for the dose response up until this point. We've only taken the very last time point, so the 6.5 hour or the 3 hour, whatever the last time point was. But if you take the intermediate data and you look at the first 3 hours, which on this are the blue data points, then you see a greater response to ozone than if you look at the 5 to 6 hour data points, which are in this case, the red data points. And I'm gonna work on sending that out right now.
Well, let's just do this. Can you pull up your former presentation?
I'm having technical difficulties.
Okay, okay, but we have the handout, do we not?
Yes, everybody has it.
Okay, so the graph that we're looking at
No, it's not. but
looks
there's similar-
roughly like slide number, I'm gonna just say 6.
They are numbered, but they're like,
I'm sorry?
Yeah, like 6.
All right, so if you look at your handout and look at slide number 6, the figure that we have in front of us is it's a blizzard of data points. But there are 2 lines on it, and the lines look somewhat similar to the solid blue line and the solid red line. The difference here is that if you're still looking at number 6, the solid red line is composed of the intermediate time points of the whole experiment.
yeah, well, they're both the intermediate time points of the whole experiment. Although there are some later last.
And the red dots, they constitute what is on this thing, the blue line on the top.
Sorry.
That's okay, that's fine. Those are the beginning and the end time points. I mean, when I say beginning, I mean pre-exposure and end of exposure.
These points? So these points could be anywhere between 1 hour into the experiment and 6.5 hours into the experiment. This is from maybe 9 or 10 different experiments.
Okay, but the top line is a longer term
The
exposure.
top line is 5 to 6 hours of exposure, the bottom line is less than 3 hours of exposure. 5 to 8 hours.
See, so Dr. Utell, we were talking earlier about upregulation and protective enzymes. If these concentrations were steady concentrations, and there was a steady replenishment, you really wouldn't have expected much difference between these 2 lines. I don't think. So it
Right.
almost sounds like we have upregulation going on. I mean, how else would you explain that?
Yeah, at first blush, that's correct, because it should just continue if you replenished.
And that's something Dr. Phalen said earlier, it's about your body's adapting. I mean, that's intriguing. Okay, so you're gonna make this a part of the whole record?
Yep, working on it right
Something to think about overnight.
Sure. Yeah, we can think about it overnight, that's great. Okay, so we're still back on question 4. How do we relate exposure conditions and adverse outcomes in controlled exposure studies to the general population, including sensitive individuals or subgroups? So these
The changes are so small.
these subgroups, I mean, we have subgroups in your figure. Can you show us,
Just
oh,
percent.
we're still having technical difficulties?
Just a
Percent
two-
change.
Slide
It's just-
7,
It's just a 2% change between these 2 lines.
Please.
I don't know if it's
There's a
meaningful.
big change out here.
Well, that's different.
Yeah.
All right, so here is an example of sensitive subgroups, right?
now. Yes. Yeah, all
Okay.
of the gray, all of the gray ones are sensitive subgroups.
Okay, and again, the total dose on the bottom is ppm times liter, which is a function, the liter is a function of time versus ventilation. Okay,
And concentration.
yeah, that's the ppm.
Yep.
Okay. And so the question relates to how do we take this information from a controlled exposure to the general population? Any thoughts, gentlemen? Yes, Dr. Phalen.
Some years ago, I was asked to help the city of Los Angeles determine exercise criteria and indoor-outdoor criteria for kids during ozone episodes. And ozone episodes then were kind of large, like maybe 3 ppm, that kind of thing. Not 3 ppm, 0.3 ppm. And what the school system was doing was, when there was an episode, they were having all the kids stay indoors. So I contacted as many pulmonary physicians as I knew, and they said, my God, get them outside. because the indoor air is full of microorganisms and allergens and all kinds of things. And then I asked about exercise, and the bottom line was, don't deny them exercise, but don't force them to exercise. So let the kids decide. So the final recommendation was, for competitive sports, cancel them, because there the kids don't have much of a chance. But if it's just voluntary play, go ahead and do it. So that was where we came down on that. And that basically was the application of what we knew from toxicology and clinical studies to kids.
Okay. Other thoughts or comments on that?
I mean, so there are recommendations, and Bob just touched on them in terms of how these changes in lung function are applied in terms of primarily school kids. I hadn't heard quite the same, that have them go outside, but it probably is fine. And then, you know, the clinical studies would tell you that they might well have some change in their lung function. And I think Lippman showed this years ago in a camp study in upstate New York, where the kids, they had a high ozone event, and the kids were exercising, and they showed decrements in lung function. So I think that's perfectly reasonable. You certainly wouldn't make them exercise. And would you try and control it? You might, depending on how high the level is. But the chamber studies, in terms of extension to the general population, are really related to short-term effects. And you need to interpret it in that light, and primarily related to children, and maybe asthmatic children or asthmatics in general. You know, common sense would tell you that exercise on a high ozone day carries with it some increased likelihood of a greater reduction in lung function. And, you know, you'd probably try to avoid that.
But Mark, the physicians said that staying in a classroom was very risky in terms of infections being spread, and also that kids need exercise, and they need the so-called fresh air.
Yeah.
And the ozone levels, although they were high, weren't enough to alarm the pediatricians and pulmonary people in the LA area.
Okay.
Well, now that if you look at these studies that Dr. Lange and others have done, and we go to slide, can we go to slide 10, please? So slide 10 is this table. And this is, Dr. Lange's already answered the question. What struck me a little bit different is that US EPA and others, it's just not EPA, uses this idea of ventilation rate of 14 liters per minute, or 20 meter cube per day, for a lot of work. And of course, we have all sorts of ventilations we could use. From the point of view of the controlled exposure studies, which ventilation rate would be a little bit more appropriate for the general population, including sensitive subgroups? Is it gonna be, you know, the vigorous biking, I suppose, or sedimentary? I mean, if we could go to those two extremes, are either of those extremes reasonable? I think one of them's not reasonable at all. That would be sedimentary, but what about the other one? Any thoughts on that? That's slide 10.
Why is sedentary not reasonable?
Well,
It looks awfully low.
well, it is low. I guess what I'm used to thinking of other air toxics as the US EPA 1994 non-occupational, that row. And it's, you know, it's 24/7. How much do you breathe per day? 20 meter cube per day. And all of EPA's reference concentrations, or nearly all of them, probably all of them, are on the basis of that ventilation. and we set safe concentrations, or EPA sets safe concentrations, and other people do this as well. I mean, it's just not EPA, on the basis of an averaging time. Well, it's 24/7. That kind of makes it easy, and that's the ventilation rate. Now, the ozone averaging time is different, and of course, we have these controlled studies, some of which are, not over-exercised. There are some studies where it wasn't done, and some of them were exercised. The question is, we can integrate all this information, which I think is what Dr. Lange has done with these graphs. But once we take the integrated information and come up with these apparent thresholds for 5% or 10% or 2% for that matter, decrements, or I guess to use the ATS definition, a decrement that's associated with some symptoms that are related. I mean, we could use that. The question then becomes, how do we interpret this? What ventilation rate do we use for the general population? How do we do this? Any thoughts on that?
Well, I don't know that these numbers are so bad. The non-occupational exposure of 14 liters per minute, I mean, most of us, assuming people in the audience haven't fallen asleep, they're breathing probably 8 liters a minute, right? 7, 8 liters a minute. If they're excited, maybe at 10. And if you average it out, the amount of time they're sitting and so on for adults versus, here they actually have heavy physical labor in there, and they're still
Right.
coming out at 14 liters. It might be a little bit high, but it's not an unreasonable number, I don't think. 22 liters for someone doing manual labor, again, if they're doing really heavy physical labor all the time, that's probably a little low, but if you're averaging it out over the 8 hours, it's probably about right. I don't know. I think that those kinds of numbers are okay. Samet had some numbers for vigorous activity, and you can see that's much higher. He's at 65 liters.
Right.
And I think some of the McDonald numbers, I don't remember, those were up around 50 liters a minute.
For some of the experiments, yeah.
Yeah.
Yeah, most of them were down lower in the 40, 35 range, but some of them are higher, yeah.
The numbers that were on the graph that EPA is using were 32 to 38, were they not?
They were, but that doesn't, that is taking all of the studies that were done at different ventilation rates, and then making them all have the same ventilation and exposure time, and then pulling out a concentration. So the basis for those numbers were not all, those actual experiments were not all done at that exact same ventilation and exposure time. Some of them were done at shorter exposures, higher ventilations, and that sort of thing.
Okay, but I want to make sure I understand what you just said, Dr. Lange. If you go back to slide 4, we can't, just on go back to slide 4 on your handout. This is the graph that US EPA used, was it not, in part?
It's the basis of their model.
And the ventilation here, as you've got, is 34 to 40 liters per minute. That's Dr. Utell's question. Sure.
That's the assumption that they made to make this graph. Some of the underlying data that went into the curve
Was higher?
was higher or lower.
Okay.
Yeah.
That's an average.
Yeah, it's an average.
Did that answer your question, Dr. Utell?
It does, yeah. I mean, I don't know what the right number is, but I think the two numbers that the EPA was using seem reasonable.
So when you say the two numbers, you mean what US EPA uses for other toxicants?
So, no, so the non-occupational and the occupational, in terms of manual labor, I think those ventilation rates are probably,
All right, so the 22 and the 40.
and the 14, yeah.
Other thoughts on that? Dr. Maldonado, any thoughts on that?
No.
I'm getting better at that.
I
Yes.
think as long as one realizes these are averages, and that if you have better data, like you've got a worker who exercises harder, you use those data. Or if you've got kids that are on a 20-mile hike you know, and they're 11 years old, you use those data. So as long as these are just seen as default data when you don't have any better data, I think it's fine.
Okay. Dr. Ryan, did you want to add to that?
I don't think so. I think we've discussed what we needed to discuss on that.
Okay. All right, so let me ask Dr. Utell, you had said that this information that Dr. Lange presented was interesting, had it been published, but working this up makes sense to you?
Well, it does. I mean, the question is, if you're exposed to ozone, let's say for 6.5 hours, and you had a substantial drop in your FEV1 over the first 3 hours, I would have anticipated that it would continue. And if I had asthmatics, and I'm not sure, one of your slides shows asthmatics. Typically what happens is, assuming they're actually bronchoconstricting, it's just not loss of lung volume, but they're bronchoconstricting. One might have thought that when they stop for the 10 minutes and then have to start again, you'd actually see greater decrements in lung function, and that's not what this seems to be showing. And so it's not simply that there's kind of a linear relationship between the time that you exercise and the decrement in lung function. It falls off, and I don't know why that is, except for the hypothesis that's been talked about. But I think it is a different perspective than most have had, kind of looking at this.
Okay. Yep, clarifying questions, sure. Go ahead.
So we've been talking about how to relate kind of the exposure conditions and ventilation rates to the general population, but we've missed the big question is, okay, so if we're gonna relate this to the population, what does it mean? Where are we seeing adverse effects? The NACS doesn't take ventilation rate into account, so considering that and working backwards, what dose level, what exposure scenario do we need to, should we be considering, or should EPA be considering in setting the NACS? Like, where is it adverse?
Well, okay. And I guess let me clarify your question, I think. EPA looks like they're focusing in on, Dr. Lange, if this figure is correct, they're focusing in on 32 to 40 liters per minute, right? Is that what they're doing?
They're not really doing this. They're focusing on 60 parts per billion in the Kim et al. Study, and they're focusing on 72 parts per billion in the Schlegel study, not taking this ventilation rate into account.
Right, so they're assuming this particular exposure scenario, which is the 32 to 40 liters per minute, and the 6.6 hour exposure with the 50 minutes of exercise every hour for 6 hours. Those exposure conditions were used to show, in one circumstance, a statistically significant FEV1 decrement at 60 parts per billion and one at 72 parts per billion, and that's been a major focus. The decrements have been on the range of 1.5% FEV1, the group mean, and then for the 72 parts per billion in the range of 5.5.
Okay, so I'm sorry, I'm confused. So what you're saying is EPA is focusing in on a concentration, sure, they have to work it back to that eventually, but a ventilation rate that's in the range of what this figure shows of 30 to 40 liters per minute.
That's correct.
And what we have here so far is, it depends on who it is, that's Dr. Phalen. If you have exercising kids, perhaps, or if we have the general population, we've got this number of 14, which, EPA uses already, and 22 for workers.
So, I don't know how to answer your question. I'm not the EPA. They're basically, as you're explaining it and it's being explained, they're taking the lowest concentration at kind of this high ventilation rate and saying we can see an effect, right? That's what it amounts to. What is the lowest dose, lowest concentration, not dose, lowest concentration that can be seen to provoke an effect. And it's irregardless of the ventilation that got you there, it is saying that if you want to stress the system, you can see a decrement in lung function in the two studies that you just, in the Kim study and the Schlegel study, at these lower concentrations, but presumably to get there, you need to exercise at 30 to 40 liters per minute. I mean, that's,
But there's also a time element there that's, completely outlandish as well.
well, but the,
6.6 hours.
well, but they're stressing the system. I mean, that's, at that time point, I mean, maybe if you went 10 hours, you could go down a little bit lower. It certainly looks like, from the way these studies have evolved, the 6.6 hours, that, as you increase the exposure time, as you increase the exercise, you're able to see effects at lower concentrations.
But they're just focusing tacitly on turning the one dial, the concentration level down, without fully explicating that there are two other dials involved.
Well, that's Julie's point, I think, that,
So if you scale everything back up to a common denominator, it looks fundamentally different.
Okay, what we're gonna do, if you have to make comments, that's okay, especially if we recognize you, but you have to use a microphone, because no one on the webinar can hear you. All they hear is the answer.
You're supposed to be on cards.
Well, we have cards for that. We have a question from our
Well,
policy group?
I guess I want to take it back and relate the slide 4 to 14 and 15, Dr. Lange, and just and get your thoughts on the Schlegel study, book 72, PPD. How would you recommend, I guess, that the administrator use what you've done? I look at 14 and 15, and it appears the lines are on top of one another, virtually, and they're all way below the FEV. And I look at slide 4 and I see something else. And so I guess I want a little more explanation of the differences that generated 14 and 15, because it tells me there's virtually no difference between 70 and 75, there is a bit of a difference between 65 and 70 on slide 15, but no difference, and all well below the FEVs.
So that's a great point. The difference between Schlegel and Kim it's actually exactly what Mike Dourson has been kind of pointing out, which is the difference between the experimental exposures and exposures that we would expect to happen in the population. So the basis of these numbers, that the doses that I show you on slides 14 and 15, come from diary data primarily, where the ventilation rate and exercise time was actually measured for different groups, and that's on slide 10. And that's the first set of numbers. This is from US EPA 2009. What that shows is, so what I used are the actual exposure numbers that you would expect. So for a moderate exercise, which is what EPA calls this, it's actually closer to moderate high. It's higher than moderate ventilation rates at this point. For a moderate, for children 6 to 11 years old, moderate exercise intensity, we would expect a ventilation rate of 21.6 liters per minute, and we would expect them to be doing that for 2.6 hours. The exposures the exposure scenario that's in that McDonald slide on slide 4 is 6.6 hours at 34 to 40 liters per minute. So that is well above the exposure scenarios that have been measured in the population. So that's the difference between what you see in McDonald and what you see in mine. I was trying to use the known real-world exposure scenarios that have been measured and published to say these are the doses that we would expect to see with those exposure scenarios.
And are those, I guess, then on slide The known, the known that you're using.
The known that I'm using is slide 10.
Give me some more words around known. Conservative, realistic, what does known mean?
Known means measured. So there have been,
But in what setting?
right, so
Well,
I'm drawing a blank on what it was. This is the basis for the Consolidated Health and Activity Diaries that EPA uses in their modeling, so these CHAD diaries.
Right.
And what happened was a group of study investigators called people, and they had them say how much they were exercising and for how long. And there's about 8,000 people.
Wow.
I would have to double check, it depends on the age groups and stuff, that were called and polled to find out what their intensities were and what the duration was. So that's what I mean by measured.
okay, I was just picking up on the comment, I think earlier, of
Absolutely.
stress the system and, a realistic versus, I guess another way to look at it, at least for me, is if you did your analysis using the, I guess it's not a footnote, but what's on page 4, as far as the parameters, if you ran your entire analysis through those parameters, the 20, 34, and 40, 6.6, would your result have been identical then to McDonald? Or would we see differences, other differences pop up?
It's the same as McDonald.
Okay.
Yep, I've
So,
done that. I'm
so,
not showing it
so
here,
we're
but-
honing in then on the differences that led to the graphs on, this is what I'm trying to get at. What are the differences that led to your different graphs on the final 2 slides?
Right.
Got it, okay, very helpful, thank you.
The
Okay.
other, sorry, can I mention one?
No, go ahead.
So the other thing, and this relates to what Mark Utell was talking about with the differences in exposure times, so the less that you get lesser effects as the dose is, the dose time increases. The McDonald data takes all of it and puts it all together, but if you separate it out, you see the same 2 different curves. So this is an average of all of 1 hour to 8 hour exposure times. But more accurately, you would separate it out into a shorter exposure and a longer exposure, and you would have 2 different curves.
Okay, so that brings me to a question here, and based on that and what Dr. Knaus said. So if I go to slide 4, can we go to slide 4? Dr. Martinez. So if this is all one curve, if you separated them out, the top solid curve, which is the mean response, would be 2 curves, where the shorter term would be running off to the left, and the longer term would be running off to the right.
That's correct, yeah.
Okay. Now, I want to go to what Dr. Knaus said, because he said if you ran it the way these guys did, you come up with the same answer. But if these gentle people, so I'm going to reverse the question, if these gentle people didn't run with 34 to 40, but use this other set of numbers, 14 or 22, or exercising kids is in the range of 22 for moderate. If you did that, all 3 of their if they did that, all 3 of these curves, the below, it's the 10%, 15, or 20%, they would be pushed off to the right, such that, just to give one example, if you look at the curve, the mean FEV1 at 5 for that first curve of 10% is at an ozone concentration somewhere near 70, I don't know, it's 70, let's just say it's 75, somewhere in there. It would be pushed off to the right, so it wouldn't be 75, it would be something higher. Is that correct?
Yes, it would be.
Okay. Other questions from policy panel folks? Okay, we have some questions. Yes.
were based on these diaries, right, the diary studies.
The ventilation and duration that I used for my graphs, yes, were based on the diary
So
studies.
let me ask the other panel, is that more preferred than any other kind of single type of study, that type of thing? How much? Yeah, my question has to do with how Dr. Lange generated her information based on diary, and whether others on the the panel view that as a reliable or, preferred source of information to individual types of studies that are conducted, or am I just going off the beam here?
Well, preferred or non-preferred, I think
Yeah.
what it does is it gives you another perspective on exposure, right? It says, let's take I want to say more realistic, but it has the downside of being a diary sort of phone call, right? Where, there's questions in those data sets too. Bill McDonnell probably measured everything, with incredible accuracy. So the numbers, you have confidence that, knowing Bill, that those ventilation rates are what they had. The diary says there's going to be more noise in it, but it's closer probably to what the general population is. All of this stuff is an integration of all kinds of information, because as I said earlier, there's really no perfect way or even very good way to get at some of the questions we're asking. So you integrate the data and then you extrapolate it to the situation that you're concerned about, and people are going to extrapolate it a little differently,
Great,
But-
thank you.
All right, Dr. Ryan?
Just like any data set you collect, there's strengths and weaknesses. The CHAD data set is the largest one that I know of that does time activity work. Probably the weakness of it is it's from circa 1990. So those data are just getting old. I don't know if the activity patterns have changed since that period of time or not. I simply don't know, but 8,000 people is bigger than anything that anyone else has done.
Okay. We have a clarifying question from one of our,
Yes, I'm not a panelist, but I play one on TV. I just wanted to, first of all, I think this analysis is great, taking a look at the total dose, and as we talked about in the off time. I'm kind of wondering if there's a way to reconcile some of the higher concentration data. So for example, you looked at data for 65, 70, and 75, and basically showed that the dosage was essentially the same, as Chuck already pointed out. When you get to much higher values, I'm just kind of wondering where you start to see this divergence. If you really want to line up the McDonald study or any of the other dose response curves, you probably need to start to look at where do I start to see a divergence in terms of total dosage, if you're looking to do that clarification. If not, if you're looking at a fairly narrow band in dosage, what it says to me at least is that what these studies have shown really is just individual response differences as opposed to responses to dosage. So I'm just wondering if you can reconcile this. I realize this is new data and it's very exciting, but if you can up the dosage to the point where you start to see that divergence, where your slides 14 and 15 are now showing a real spread, that to me would kind of show where you should expect to see some kind of response change, a la McDonald. I'm just again, new data, but it would be very interesting to see if you could do that kind of comparison to merge the two, to see where those two merge.
okay, so Dr. Lange, you get to go first, and then our panel second, and then I've got some questions from the web
From the audience, too.
and from the audience. Dr. Lange?
You're right, that would be interesting to see at what concentrations or different ventilation rates or different durations, depending on which parameter of dose we want to play with, at which point you do see a difference. I think concentration would be interesting to look at, because we are talking about the level of the ozone max. We haven't tried that. It would be good to see where do we start to see significant differences. I agree. It would be good.
So one question for you though, the 6.6 hour, were they done at higher dose? I just don't remember, because the whole objective of the longer studies was to do it at lower concentrations, and you might have some information, but I bet there's not a lot. I mean, it really was done. They started, I think, at 80 ppb is where it's
Up to 120.
up to 120.
Yeah.
Okay, so you got a little bit of room.
Well, yeah, a little bit of dose room there. Yeah, especially there are some with higher ventilation rates, so we get to higher total doses in some of those. And there are some 7.6-hour experiments and 8-hour experiments to get some higher total doses.
Okay. Here's some questions, this one from the audience, Dr. McClellan. Question, comment, the importance of the dialogue relating to the 2 controlled exposure studies related to dialogue between CASOC member Fred Miller and CASOC chair Chris Fry at the last CASOC Ozone meeting, and an attempt by Miller to define a science-based, in quotes, upper limit for the 8-hour averaging time standard, less than 72 parts per billion. So that's a comment. So it's this discussion's come up before. Here's a question from Andrew Huskama, and I think it's an audience member. I apologize if I got your name wrong. Several other countries and the WHO have concluded that ozone levels lower than the current standard in the U.S. are what should be considered safe. Have studies in other countries or by the WHO show different results than the U.S. studies? Thoughts by anybody here?
I don't think the chamber studies have been done with the elegance of some of these longer studies. They've done some very nice studies in Europe, but they tended to be shorter term. I don't know the epi well enough from Europe to comment. Maybe, George, you do.
No, I don't.
Yeah.
Microphone.
I mean, the epi studies are done all around the world.
Yeah.
So,
Let me go back to, I didn't give everybody on the panel a chance to comment on Dr. McClellan's statement, question. Pardon me.
Let's see, I'd like to hear what he was gonna add.
Okay.
Well, going to that, the court case, Mississippi, in the interpretation of some individuals, including EPA attorneys who advise Chris Fry, the chair of CASAC, and Fred Miller, left open sort of some room for how one might provide a science-based value in terms of this guidance from CASAC. So there was a lot of back and forth, and Fred Miller, acting sort of a drugstore attorney, came up with this view that you could go from those 2 controlled exposure studies, and the interpretation of those is that the standard must be set lower than 72 ppb. What Dr. Lange has done is simply, I think it's some superb work, but it is mathematical gymnastics. You start with the studies, and then you use some assumptions, and it gives an alternative view as to how you can interpret those studies. And I think that's extraordinarily valuable to the administrator. But that's what was going on, because CASAC is trying to somehow say there's a science-based approach to what we're telling you. Coming to this last question, remember again, any time that you're going to talk about levels in a standard or guidance, you have to talk about averaging time. And if you want to talk about the stringency of it, you have to talk about statistical form. So it becomes very challenging to compare values from around the world. The fact that a number is lower in some country than what it is in USA is meaningless until you interpret that in terms of averaging time and the statistical form, and whether in fact in that country it is a legally binding standard, as in the US, or it's a guidance value.
Okay, good point. Other comments to either, to the WHO question, the question that came up about other countries? Okay, so we're still on this question, how do we relate exposure conditions and adverse outcomes and controlled exposure studies to the general population, including sensitive subgroups / individuals? That does, I mean, we do have some interesting work. I think the panel is suggesting, push on it, maybe get it published or something. I don't want to overstate that case.
Well, if you want to see it have any significance in any play, you better get it published.
Right.
Yeah.
The fact that we have different, the one chart that has differences in exposure, ventilation rates and durations based on the US EPA 2009 work, which is the 8,000 people survey. Of course, there is some uncertainty with the survey, but it is 8,000 people, and it is, it's data versus for individuals. We have on this chart, you could use the 14. Again, I'm just repeating myself. EPA does that for other toxicants. We have the 22 liters per minute for workers. We have, as Dr. Phalen has said, you have who is their population of concern. If you have exercising kids, you can go into that and say, okay, we have moderate or high exercising. You have different durations. I guess with high exercise, it's 0.3 hours. But the point is, you can work those, you can use those kinds of numbers to come up with doses, that is concentration versus time. And essentially, this is what you've done on the slides 14 and 15. Let's just make sure then. So if I go to slide 14, can we go to slide 14? Thank you so much, Dr. Martinez. Okay, so what you have here is, these are the data from the survey at the below. So that's number 14 is moderate exercise child, high intensity child exercise. The reason you get a lower total dose for high intensity child exercise is because they only go 0.3 hours?
That's correct.
Okay, so it goes counterintuitive to what we would think, but not if you're doing total dose. I see. Okay. We're going to have a clarifying question here, and then, okay, go ahead.
So, this is similar to what I asked before, but I didn't quite get an answer, I think. We have there's 4 studies that have looked at ozone concentrations, regardless of ventilation, below 75 parts per billion. Adams, 2002 and 2006, which reported no effects below the current level of the NAAQS. Then you have Kim, that only looked at 60 parts per billion, reported an average FEV decrement of 1.71%, FVC decrement of 1.19%, and out of 59 people, 3 who individual decrements greater than 10%. Then you have Schlegel, who did not find any effects at 60, but did report a statistically significant small group mean lung function decrement of 5.3% for FEV1 after 6 hours of exposure. And there were some other limitations of this study as well. Like, for instance, the time period between exposure of filtered air versus exposure averaged 55 days, ranging from 13 to 302 days. So there could be other co-exposure, seasonal changes, or other things contributing to that difference. So, it's very clear, EPA put forth, recommended a potential standard between 60 and 70, and then the administrator put forth 65 to 70. Those numbers are clearly coming directly from these studies. So my question is, do these studies support a lower standard or indicate we need a lower standard to be health protective, or do they indicate that the current standard is health protective, keeping in mind everything we've discussed today and the analysis that Sabine showed?
Yes, that's gentlemen, I'll give you
Yes or
5
no?
minutes to answer the question. No, that's a fairly complex question.
As we would say, you need more research.
No, but we need an answer, right? Is it?
Well, look,
That's the question.
there's no yes and no answer to this. The reality is there are very small effects that probably are not impacting the public health, given the data. You have a couple of studies that are negative. You have one study that shows a 2% change in lung function. What it says to me is that in some part of the population, at these low exposure concentrations, you can get a small decrement in lung function. Do you use that as the basis for modifying a standard? Scientifically, clinically, I don't think so. Okay, but I'm not that's not my call, and the data don't let you say you need to do this to protect the public health. The public health is seemingly well-protected, given those limited studies that you just went over. I guess the thing I would go back to, Julie, is I don't, I haven't looked at how CASAC and the process is working, but I don't think it's in isolation on just those 4 studies. I mean, they're going to argue that there's epidemiology that's supporting what they're doing. I know they've argued that the lavage studies support what they're doing. And so if that were the extent of the database alone, then there's very little there to support their argument. I'm going to, I suspect the epidemiology isn't all that much stronger. There are clues that say you may see some effects. Is it a basis in terms of protecting the public health? From the position I look at it, there doesn't seem to be a whole lot there, but you certainly wouldn't make that call. I shouldn't say certainly. I think it's unlikely that you would make that call based on the 3 or 4 controlled clinical studies alone.
Okay, other thoughts?
Yeah,
Yes, Dr.
I
Phalen?
think in order to revise the standard, I think you need really extremely strong evidence that is necessary in this case. And I don't see that strong evidence. So I would not think a revision is indicated.
So when you say strong evidence, you mean on the basis of the 4 studies that Dr. Goodman just mentioned?
Yeah, I'd say that's not very strong. That's not strong enough for me in terms of what Dr. Utell has said and what our experience is. And I think people self-protect in the environment anyway. So I think that people are probably their defenses are more active in the environment than they are in the lab. But but when you're close to the current standard, forced exercise is not good. And because there may be some sensitive kids.
Okay, other comments from, yes, Dr.
Did you have a comment first?
That's good.
Julie, those 4 studies that you were talking about, they're reporting very small changes in FEV1. I'm not a clinician, I don't do research on lung function. Do you think that those differences actually exist, or do you think that could be a function just of measurement error? How accurately can you measure FEV1? I guess it's for both of you.
Yeah.
Well, I suspect they're real, because I think there's a trend downward, if I remember the studies. I mean, they're obviously small changes, but it's not, it's been, I didn't go back and look at the data, but I don't think it blips up and blips down. There's certainly variability in the reproducibility of a spirogram, okay?
Is it about 5%
but-
variability?
Yeah, I mean, there is in a population,
Okay.
in people who are, in a study, you've got very good technicians, it's probably a little less, but nonetheless, my recollection isn't that they blipped up and they blipped down, it was over time, you saw sort of this small change in lung function going as the curves we've looked at. So, is it just measurement error? I doubt it. I mean, if it were, how many people were in the group? Do you remember?
Kim had 59 and Schlegel had 30.
Yeah.
And Adams each had 30.
Those are
Well,
small numbers.
Those are pretty good, though, for clinical studies.
Small,
There's
small in terms of
there's a
measurement.
paper that has 3, and I was a reviewer, so
Oh,
I thought it was
gotta
an
be good
interesting
then.
paper. But, as control studies go, they're complicated, they're expensive. 59 is pretty darn good. That's probably at the top of the
But
curve.
EPA focuses, because we've argued, and this gets into too, even if it's real, 1% is running up the stairs, right?
Right.
Or actually,
Yeah.
more, I don't know
Well-
exactly what running up the stairs is, but what they focus on is that they're saying the average doesn't matter. What matters is individual measurements. And as I said, Kim had 3, and I think Schlegel had 6 people with measurements above 10%. And so it's because of those people, you know, that those represent sensitive people. And
Were those 10% changes clinically important 10% changes, though?
well, no, and actually in Schlegel, we obtained the individual data from that, and there was actually no correlations with the severity of symptoms and FEV measurements. So even the people with a higher FEV decrements did not have more symptoms.
So that would go back to the ATS definition of adverse effect. You need kind of both.
Yeah, so,
But I think,
Okay,
These are
Other-
they're pretty small changes. That's all you can say.
okay, other thoughts on the clarifying question? Okay, we're still on number 4, and we have plenty of time all of a sudden, which is, chairs always love us to see that. So I'm gonna ask a couple of these questions. This is a question from Stephanie Shirley, webcast, if this has not come up. So she's suggesting maybe hasn't come up yet. The EPA risk assessment document estimated decrements of FEV1 occurring once or more per year in populations of interest. These results appear to be the basis of the proposed, i.e. more stringent standard. The analysis presented by Dr. Lange seems to imply that personal exposures would not reach sufficiently high doses to cause the proposed health effects. Is this correct? And I think she's referring to slides 14 and 15. Is this correct?
Can I hear it again? Just
Do you want to read
there
it?
were lots of pieces.
Why don't you read it again?
The EPA Health Risk and Exposure Assessment estimated decrements of FEV1 occurring once or more per year in populations of interest. These results appear to be the basis of the proposed more stringent standard. The analysis presented by Dr. Lange seems to imply that personal exposures would not reach sufficiently high doses to cause the proposed health effects. Is this correct? The exposures based on the diary data do not seem to cause high enough doses to achieve high enough FEV1 decrements to bring it maybe to the level of an adverse effect. That's what the 14 and 15 seem to say to me.
Other comments from panel members?
we have one for
Okay, that's fine. Go
Hi,
ahead, sir.
David Stern. I'm not a health science expert, but I'm trying to figure out how to reconcile something. You know, EPA, I'm going to take us back to the first talk, which is the first part of the discussion, which is about mortality and morbidity. So we're here debating whether there's some FEV1 decrement or not, which is likely transitory, right? And there's no evidence to suggest that I've heard so far that says that it really is long-term. But yet, we're talking about mortality, morbidity. I'll turn it to the thoracic experts on the left-hand panel here. What do you believe about true long-term effects due to ozone exposure of the types that we're talking about here? Some that might make a difference between, say, 84 and 75 or 75 and 70.
Okay,
Well, we really haven't gotten to the studies that are going to let us address that kind of issue. I mean, the chamber studies are truly short-term, and by design and by, you know, ethical issues, these are short-term with reversible effects. I would say from the studies we've discussed so far, there's nothing here to suggest that there's a permanency to the effect. The way I look at it is to say, is there a clue in these studies that suggests a mechanism or a mode of action that with continuous or ongoing exposure, there is a risk of progressive disease or morbidity or mortality. And whether that exists or not, I would propose we hold off until we go to the epidemiology studies, which my colleague here is going to opine on tomorrow. But I don't think, the controlled studies don't do that. They don't have that capacity. They're not designed to do so. They're saying two things. One, do you see a response? And the answer is, again, very much dose and concentration dependent. And then do you see something in those who are more sensitive? Because you can look at those populations. And do you find clues as to mechanism of action? But the serious morbidity, mortality really comes out of the epidemiology.
Okay? Yes, Dr. Ryan.
That's known as a punt.
Yeah, we're talking about epithelium, and in animal studies, when you've done long-term studies, you see the adaptation. You would have had a focal injury throughout the lung, and then you'd see a resolution of that. In the skin, when you have sunburn, you see injury and you see resolution. So the concept came up that could prolonged exposure, if there was recovery, initial re-injury, recovery, re-injury, have some cumulative effect, or you could think of it as incomplete repair after each incident. We looked at C times T data, and actually we found that the responses for pulmonary injury were proportional to C squared times T. So that means at lower doses, we're less concerned. So my judgment, without going to those low doses, that looking at the doses that we did look at, down to maybe a half a part per million, 0.3 of a part per million, long-term cumulative injury is probably not a problem. It would be analogous to light, infrequent exposure of the skin to sun, rather than the heavy exposure that leads to premature aging.
Okay, good. Okay, I have some other questions. This one is from Steve Packman. Can slides 14 and 15, Dr. Lange, that's number 15, I believe, address the Goldilocks clause, sufficient but not more than adequate? Or are slides 14 and 15 relevant to the Goldilocks clause? This is a question for you, Dr. Lange, and for the whole panel, actually.
Goldilocks.
That was, I think, referred to some way earlier today, Goldilocks, yes?
Yeah, I think it's in reference to the standard should be set low enough to be adequately protective of public health, but not too low. So they're calling it, yeah.
Right.
Just right.
Yeah. Just-
Okay,
it's
now that
just
we
right.
think we know what that question is, go ahead. So does that,
My short answer is I don't know. I've not thought about it in those terms. I guess it could be used. To be honest, I'd have to think about it a bit more to think about how to apply it to that. And it's not really it's more into the policy realm, so a bit trickier for me to answer that, but happy to let somebody else give it a shot.
okay? Yes,
Right.
Dr. Ryan?
Yeah, I just think the last two questions really are more in the policy realm than they are in our realm here for the science. I mean, it's, we're here to decide whether or not these things are, appropriate experiments that have been done, appropriate analyses that have been done. And we give that information to the policymaker who decides to do what
Right.
they'll do with it.
Wait, can I agree, our job is to look at the science, not policy, but it's not just whether the studies have been done well, but it's also to interpret those studies to say, where do we see the adverse effects? I mean, I think that's part of it, don't you?
No, I agree. I think the interpretation of what it means from a health perspective is something we should be involved in. Where the numbers get set, that's another group who does that. But you give your opinion and you try and base it on what, not just the quality of the study, but really what you think it means in terms of health. And then, as we've heard earlier this morning, the decision gets made as a policy decision using that health data. I don't know anything about Goldilocks, so I'm gonna.
Well, I guess that, Dr. Lange, I come to a question then. You could take slides 14 and 15. Can't you, with different exercising individuals or ventilation individuals, couldn't you come up with different, I think this goes to what was said earlier by Dr. Phalen, can't you go to different standards based on who you are? I mean, you could put a table together that has, you know, for the sedimentary child, the standard would be higher than the moderately exercising adult. Is that something that could be done?
In the past, you know, the standards were set to protect basically, well, there were several standards, but you could set a standard to protect the sedentary and then say that exercise should be curtailed when this is exceeded.
Okay.
And that would be recommended, and definitely I would recommend scheduled children's sports not be conducted when you
Okay,
are
that was,
over.
okay.
But
So how would that, I mean, you could take this information and put that into a table, and then, I'm not saying the administrator would, you know, pick one or the other, but you could give guidance, I mean, you can give science guidance as to what a particular standard might look like if they were, the administrator was to focus in on a certain set of people, an individual or whatever, or whomever, right?
and-
Yes, yeah, you could do that, and
yeah.
in fact, we presented that in the pre-workshop webinar, so if you go to that clinical presentation, there's a matrix in there of, and
Oh, there
again,
is.
it's quite confusing because there are, it's a four-dimensional problem. There's 3 different components of dose, and then you have to consider the FEV1 response, so if somebody has a question, I'm happy to explain that particular matrix that is on the web. But yes, you could use it the other way and say, if we want to protect these people at this ventilation for this amount of time, this is the ozone concentration that would generate a 5% FEV1 decrement or a 10% FEV1
Yeah,
decrement.
and I may
whatever
have
you're
said it
interested.
wrong, but if you had a standard, then you'd have a caution to say, when you approach the standard from below, exercise is not advised.
Right. So maybe you can draw out the, Dr. Lange, maybe you can draw out that, you say it's in our pre-meeting package, or no?
It was in the pre-meeting webinar.
Okay.
It's, I don't think it's in the, I don't think it's in the package that you're holding in your hands, I'm sorry.
If you could, yeah, if you could, if we could have that done, so we could just pass out those. Not now, maybe later. We don't wanna do it now.
Michael, do you know what the air quality index is?
Yeah, that sounds like what this
It's
is.
very important, this conversation here.
That- We need you to be on the microphone, sir.
Yep.
And I'll be happy to speak into one.
Okay?
Roger McClellan. All this conversation is very interesting about advice. This is all captured in the Air Quality Index. If you go to the proposed rule, I think the Air Quality Index is referenced at the end. The administrator not only issues a standard, the administrator issues an air quality index, which gives advice to the public at various levels of exposure. That is reviewed by CASAC and commented on CASAC to the extent they desire. At the same time, they provide advice on the standard. So what you're talking about here, this dialogue back and forth, very interesting. It is not relevant to the standard. It may be relevant to offering advice or commentary to the administrator on their setting of the standard. But when it comes to the issue of advice to the public, that's captured within the Air Quality Index. So I'd encourage each of you to review that and keep that in mind as you develop these kinds of comments.
Right, so what we can do is also, since we're making a copy of Dr. Lange, your table, we'll make a copy of what's in EPA's guidance on air quality index. We'll just pass them both out tomorrow morning. Thank you, Dr. McClellan. I'm gonna go, this is gonna be easy. I'm gonna segue to question 5. And the reason it's gonna be easy is because we've been talking about it. So what I have for question 4 is a whole bunch of stuff, and again, we have, how many, we have like 4 note takers here, right? Which is a good thing. But I think the response to this question is diverse. This is question 4. How do we relate exposure conditions and adverse outcomes of controlled exposure studies to the general population, including sensitive subgroups for individuals? Part of this can be captured by the controlled exposure studies, especially the short-term things. Dr. Phalen also mentioned experimental animal work where they found that the relationship to damage was concentration squared times time, meaning that low concentrations have less impact, leading to this idea of long-term injury being protected maybe from short-term, a little bit perhaps. But also, Dr. Utell mentioned this idea of epidemiology studies, and we don't have that till tomorrow. So a full response to this question is, it depends, I suppose, is the response. The controlled exposure studies are important, they're going to be used. If they get used, there's some question about the ventilation parameters. There's all sorts of ventilations being suggested to the general public with 14 for work, this is liters per minute. For workers, it's 22. For the exercising child, it's 22 to 42. Of course, the timing is very different between those two sets of children, but the point is, you can use ventilation changes that are different from the controlled exposure studies, which makes it important to integrate all of that information into graphs similar to what McDonald did, or maybe what Dr. Lange did and her colleagues did. This idea of the 4 controlled studies that are kind of less than the current standard, or do they form a sufficient basis to change the standard? Well, some of the panel thinks that you need stronger evidence than that, and others perhaps you need stronger evidence if you're going to change on the basis of only those 4 studies, but there's other things that you have to fold into the decision, and some of that we'll talk about tomorrow. Now, question 5 I've got, how can the data from controlled human exposure studies be used to answer public health questions? Well, we've been talking about that for the last hour, I think. Yeah. This is just a different way to ask the same question to make sure we talked about it. So it's a question to the panel. Do you want to, how can the data from controlled human exposure studies be used to answer public health questions? Any thoughts on this?
So I'm going to give you a real issue and just open it up for people to think about. So I've been involved with the Health Effects Institute in the past, and they're in the final stages of a very interesting multi-center ozone study looking at cardiovascular responses. So we're not going to talk about FEV1. We're going to take something that is been touched upon a little bit in the epi and a little bit in controlled studies, but it's not a whole lot of data. So here's the design. They're senior citizens, not 20-year-olds, but people who are in their 50s and 60s or mid-50s and maybe up, maybe up to their 70s. Hold on. They have no history of cardiovascular disease. They're going to be exposed to ozone for 3 hours. Concentrations are 70 ppb, 120 ppb, and clean air. So everybody has 3 exposures. The endpoints are going to be plotting parameters, so looking at things that might put you at risk for atherosclerosis. There's looking at autonomic function, so heart rate variability, arrhythmias are a different parameter, and the third is a kind of endothelial function, a vascular function. So you have three different parameters that are all relatively important clinically in terms of cardiovascular function. So these folks are exercising, I don't remember exactly, but it's at 17 liters per minute. I think for 15 minutes every half hour is my recollection. And now we have a controlled study, and let's say we see something at 120 ppb and maybe at 70 ppb. So here's a whole new arena based on a controlled study for 3 hours. How does that information get looked at in terms of protecting the public health? And I don't know the answer. I'm just saying that if indeed there are effects, that's an example of where I think you'll see lots of discussion, lots of use of controlled human studies looking at a new endpoint. And, you know, it's a multi-center study, so it's being done in San Francisco, it's being done in UNC, and it's being done at Rochester. There'll be 90 people in the study. It's pretty good size as these studies go. But you know, you can see the dilemma that comes out of this. Hopefully you're not going to see arrhythmias, but you may see changes in rhythm. You may see changes in endothelial function in terms of blood vessel size. And you may see changes in fibrinogen or some parameter that suggests a vascular abnormality. And you know, we'll go through all of this once again. If it's positive, if it's negative, well, it doesn't add to the database very much. But I think it's an illustration of where this kind of information has important implications for public health. How it gets used, only time will tell. But I don't think we've talked about it, and it really is an interesting question, because you know, the criticisms of a lot of the controlled data are that they're at high levels, or that they're in just the quote young healthy population.
Right.
And so it addresses both of those to some degree.
When, and the preliminary results would be available when? I mean, we'd like to see it tomorrow.
Well, control of that I don't have, but I think maybe by the end of the year or something like
Okay.
that. I think the study is completed. The data analysis are
Sure.
just beginning.
I mean, and the way that data could be used is similar to what we already have existing. We have these controlled outcomes with lung function, and that really goes to the heart of this question: how can we use these studies?
Yeah.
I mean, I'd like to almost see them integrated with what Dr. Phalen said with the experimental animal studies. It would give us some confidence that longer-term toxicities aren't to be expected if the concentrations are low enough.
Yeah.
Yeah.
Can I have a clarifying comment. But don't you think that just like the FEV1 decrements, we're also going to be facing questions of clinically relevant effects with these cardiovascular endpoints, like heart rate variability? It's very difficult to know how much of a change in heart rate variability is really meaningful. And as you said, with biomarkers, it's very difficult to really ascertain, you know, if there is a sufficient change in these biomarkers to make it clinically relevant. I think for some of these, we do have data on that, right? Like what is a normal range, you know, for these, And even if it's statistically significantly different, if it's still within the normal range, then, you know, would your cardiologist be alarmed, say, if, you know, your fibrinogen or whatever, you know, was, you know, changed
Well,
or increased
so-
or whatever, or decreased or whatever?
I didn't say I had an answer.
Right,
or
right,
that it-
right.
or
No,
that it-
I
or that it was,
just-
or
right,
that it
right.
was simple, only
Yeah.
that the interesting thing about it is, in contrast to 20 years of kind of arguing about the FEV1.
Sure.
Here you're going to have something that is looking at a new endpoint, addresses some of the real concerns in terms of the clinical studies, in terms of the population. No, heart rate variability is a tough issue. If you saw arrhythmia, you'd have a different interpretation. So part of it's going to depend on what's seen, but it's going to reopen in some ways the same kind of question. But it does, in my opinion, if indeed it's a positive study, it begins to lay a foundation that says, I mean, is there any potential for cardiovascular effects from ozone? And, you know, it will open up another set of issues. There are endpoints in it that have more clinical significance and endpoints that are really biomarkers. And, you know, the good news is you can come back in a year and find out what it shows. I don't know.
Well, I think that's exciting work because, you know, if the idea behind the mode of action is appropriate, that you need to overwhelm the detoxifying effects of the lung lining of fluid lining, then you wouldn't expect necessarily any impacts to the cardiovascular system if no ozone is getting in. And this would really go right to that. So I could see those clinical studies being very strong together.
I think so. I knew you'd ask. I'm pretty sure they are doing the FEV1.
Okay, so at this point, we have a few other questions. This is one for the entire panel, and this is from Nathan Draws from the webcast. Have ozone impacts been analyzed for other healthy populations, for instance, those that run or exercise regularly, but have other health issues, like, for example, those on certain medications, or those that have moderate severe sleep apnea? It is always assumed that those most sensitive populations could not exercise. Is this underestimating potential impacts on the general population? Question to the panel.
So
I'm not aware of any, but.
there's a study in Europe on obstructive sleep apnea, but I can't remember if it's particles or ozone. So to answer the question, a number of other parameters have been looked at, either largely respiratory or cardiovascular. And I think Bob's brought up a couple of times the model of infectivity, looking at whether a pollutant exposure makes you more responsive to a virus. And I don't think there were very definitive answers, and I just don't remember the obstructive sleep apnea, except there was some type of interaction between the pollutant and the EEG. So the way they were looking at this was trying to look at the stage of sleep and the pollutant. And it's been looked at, but I don't remember the
About
finding.
what year?
Last couple of years.
Okay.
What's that?
Google.
Google it. Yeah, I'm pretty sure it was in Europe, because one of the guys in our group actually thought about that kind of study, just because there were some clues about, particularly with particles and effects on the brain. So
Okay.
it may be a particle study.
And here's
Dr.
a-
Dourson,
Yes.
can I just,
Yes.
I mean, that question's interesting, but, you know, as I understand, the administrator gave the greatest weight to the chamber studies and less weight to the epi studies that we'll be talking about tomorrow. So we're kind of, those are the ones that obviously we're focused on in the proposal, and I'm eager, now that we've had a good discussion on the chamber and the reanalysis essentially of the chamber studies, I did have one follow-up for Dr.
Please.
Lange. The agency had, predicted a significant number of children with a decrement over 60 ppb. And what does your study say about that perspective?
Our study is done a bit differently, and we get different kinds of outputs compared to it's the APEX model that the EPA uses. And in fact, Sonja is going to be talking more about how the APEX model works and the kinds of inputs and outputs that go into it. It's difficult for me to compare them because they were done quite differently. What I can say is that using the child's ventilation and exposure times, we're not seeing these significant FEV1 decrements. One of the additional differences that Julie has mentioned that we've discussed a little bit is that these are mean FEV1 decrements based on the mean of the population who was exposed. The EPA is focusing on those proportion of the population that would be expected to be more sensitive than the mean and would have greater than 10% or 15% or 20% FEV1 decrement. So the output is quite different.
That answer your question?
Yeah. Look
Yes.
forward to Dr. Sax's discussion.
Okay.
I had a brief question
No pressure.
to those panelists that have conducted bronchial lavage type of experiments. As I recall, the Kim study, inflammation was detected there with those 60 part per billion exposures, although only in a single parameter. What I had thought is that inflammation shows up in a number of markers, in that would a single marker qualify as inflammation enough? Is that's all you need is one of the markers?
Well, the more the merrier, Will. So it depends on what the marker is. I think, as I recall, it's the white count, the influx.
One of the cell counts.
Yeah.
But not others.
It was not. I'm sorry, it was or was not?
There was one cell count marker that was positive and the others were not.
But I thought the marker itself might have been on the white cell, but I thought that.
It was neutrophil infiltration.
Neutrophil what?
Infiltration.
Infiltration, yeah. So if you look at the ozone studies, the reproducible response has been the influx of neutrophils. So to me, that is an important sign of inflammation when you see neutrophils.
So one marker's enough, I guess.
Well, it's not that it's enough or inadequate. It just says that there is inflammation.
Okay,
I mean, there are. If you told me it was a cytokine that was up alone, I wouldn't know what to make of that.
Sure.
But with a white count, I think it's an important marker.
Yeah, the other thing you mentioned, the summer camp studies earlier in the study, Kenny did a reanalysis of half a dozen of those studies, in that what he found was, at least in children, there was a distinct learning effect of how to take an FEV1 measurement.
Yep.
And when corrected for that, that halved the FEV reported in that study. Now, the same thing happens in chamber studies, and I presume adults also have a learning curve. And so if you have a study that has maybe only 1-2 exposures of filtered air in a single concentration, if corrected for learning effects, what would be the outcome, do you think?
Well, I mean, you do try and train the subject before they participate, and then, of course, you randomize the exposure. So 50% of the subjects would get ozone on the first day, and 50% would get it on the second, on the revisit. So that would hopefully control
help.
some of the training. But the spirometry for an adult, it's not. There's not a huge training effect. You do have to spend time before they participate in the study, training them how to do the spirometry and making sure it's reproducible. But there certainly could be in children, I think, much more of a learning effect.
Okay. So we have 3 more questions from, did somebody else want to answer? I'm sorry. And what I want to do is just summarize a little bit on this question 5. How can the data from controlled human exposure studies be used to answer public health questions? We have a couple tables that we're gonna have produced overnight. It would be in our hands tomorrow morning. I don't think it'll be in our hands tonight. That's Dr. Lange's table that talks about, these controlled human exposures and her and her colleagues' analysis, putting into a table that can maybe answer public health questions. And that Dr. McClellan had talked about the administrator's air quality index, and we're going to provide that as well.
Would it be helpful to also have the 4 studies that the administrator seems to rely on most? A summary of those, Adams, Kim, and Schlegel? Okay.
Well, if you want to have the abstracts, I think we all have those, but if you want to just have the abstracts for those 4 studies, that might be a good handout as well. You can put that on 1 page even, or maybe 2. We have been talking about animal data before, and Dr. McClellan had made 2 comments here. These are just reminders. The late Dr. Don Gardner did all kinds of studies on infectivity in mice starting in 1967. So I'm presuming that's infectivity in mice with ozone. And in considering the issue of long-term ozone exposure, it is important to recall that NTP, with ancillary studies funded by HEI, conducted a 2-year studies of multiple levels of ozone in rodents at very modest effects. And Dr. Phalen, you're aware of that?
Say it again, please.
It's the NTP with ancillary studies funded by HEI conducted 2-year studies of multiple levels of ozone in rodents to the tune of very modest effects. So those are comments.
I've probably seen the studies, but I don't remember who the authors would be and so on.
Okay. All right, so as we talk in terms of, this goes to your point, Dr. Phalen, of saying,
Infectivity?
well, the idea of experimental long-term injury,
Oh, I see.
it's more related to concentration squared times time. Of course, the lower the concentration, the less impactful it is. And I have a question that I've been holding back. This is an audience, or maybe it's a web question. And what I'm going to do now is, I think we've talked enough about 4 and 5 to realize that we still need to fold in some other information with epidemiology studies before we can make definitive statements on the use of adverse outcomes and controlled exposure studies to the general population. But I want to make sure that the author team is comfortable with where we are in 4 and 5. Are there any other questions you want to ask of the panel before we move on?
I guess maybe one thing we didn't discuss was the use of a square wave exposure, so a constant exposure versus a triangular stepwise up and down, and your feeling on relating that. So Schlegel used the triangular. I think one of the Adams did too.
Yep.
Kim used the square wave. So do you feel like either of those are more appropriate, or?
I'm sure it's important, and I have no idea how.
So the triangular was, concentrations going up
Sure.
gradually and then coming down, and to simulate, somebody kind of going, during the day and.
I think that the study should simulate what you have in the environment, because the wave function shape might be important. And so if you're going to study something, study the way it really happens. And look at the ingrowth of ozone. There have been chamber studies and others, measurements in the outdoor environment. So I
Now-
just recommend the studies to use that same.
Yeah, so
rate
this
of
is
error.
also simulating ambient, obviously.
Exactly.
So the question is though, is that, is that realistic when you're really considering, that people are spending most of their time indoors and they have,
So you're saying that
they're-
when people step outdoors, it's a step function.
Right.
Then
Right.
that should be studied, yeah.
And Schlegel, what they did is they took the most extreme scenarios among 10 candidate hourly measurements of 6-hour sequences, averaging .065 to .088 across several cities. So it's kind of the worst case among these locations.
You mean for their step For their step.
Yeah, that's
Yeah.
how they chose the step function.
Well, it sort of was the evolution of the controlled studies that rather than just keeping the concentration fixed, maybe these kind of peak studies. And my recollection of why that got popularity was not so much that it just simulates kind of the way exposure happens, but the idea that if you were exercising, for example, during peak exposures, you also changed the dosing. And so it was another way of looking at a higher dose, but not exceeding kind of what the background or the ambient concentration would be. I think, as I recall, they found a little bit more response, didn't they, in those triangular, or were they just the same?
I think they were pretty similar.
By the time you got to the end of the exposure, it was
Oh.
the same as if you had the average.
Right, but early on, it looked like they were having a more significant response.
Right, but it's dose responsive, so because the triangulars tend to have a higher dose at an earlier time, you would get a higher response at an earlier time because the dosing was
Was
different.
higher.
So it was consistent with the fact that you had an increased dose rate.
Dr. Ryan?
Can I get a little bit more information on that exposure profile? I mean, I assume the integral under the curve is the same, and then don't they have to go to a higher peak with the triangular one to get the integral higher?
Right.
Yes,
They do.
yes.
Okay. I just
There's
haven't,
quite some high exposures in the triangular. And we've got the papers themselves show
I think,
by
yeah,
time, the response.
So a question intellectually would be, does ozone have good sort of warning and rapid adaptive properties? So if you were being exposed to something like ammonia, probably a real slow ramp up would be a little more dangerous because you would fatigue as you went along and you wouldn't realize when it was at a high level. But on the other hand, if there's no fatigue or response, you know, to the reflex action, then probably coming up with high dose immediately, you know, would be, well, I don't know if it'd be better or worse, but it's just intellectually interesting to ask, are the warning properties that trigger reflex breathing, do they fatigue or not? It's a question that should be answered.
So, Dr. Utell, since you were very involved in a lot of these protocols, I assume, that's my.
Well, if they were done in Rochester, probably so.
Yeah. So, was there any consideration of doing alternative patterns, maybe to simulate people going in and out of their house and traveling, and you know, it's sort of. So I'm imagining sort of you know peak exposures at like different times that then go down to like almost no.
So, no, there was consideration
Yeah.
of it.
No, I'm just
I mean,
curious.
the studies are fairly complex in and of themselves.
Right.
I don't recall, Will, one of the studies we did with you folks, did we ever do the step wave exposure? I don't think so. Will brought it up on one study, and we talked about it, but I don't believe we've done it. And I don't know if they done it at EPA. I just can't remember who's. Bazooka did one?
It was very strange, so Adams repeated it.
Right.
Okay. Well, I had one question for the panel as well. It wasn't in your thing. The controlled exposure studies, they were really good in that they did pre-exposures, of course. You walk in, before anything happens, you get a pre-exposure FEV1. They also had filtered air. So the question is, to my mind, is as a toxicologist, boy, I show my bias here, is that I would say, okay, I want to compare the responses to the pre-exposure condition, and not necessarily to filtered air, because that's not really controlled. But that's just me thinking. What are your thoughts on that?
Well, I think you do both. I mean, you have where they are at the start of the day, or at the start of the study, and then looking at their response at the end of the study, or whatever, and then you also have the other control where they've been exposed to filtered air. in my opinion, it's important to look at both, especially if you're dealing with asthmatics who may start at different baselines on different days and trying to understand that variability. I don't see any reason why you would exclude one over the, in preference of the other. You'd report both, and hopefully, you know, the data would be consistent. They usually are when you're looking at healthy volunteers. When you're looking at people with airways disease, there may be some differences. I have to go back and think, but we saw some strange responses at times that seemed to be better corrected if you looked at the effect of exercise alone. So it's coming back to me. When you have volunteers in a chamber and they're exercising, the pre-exposure, the problem with it alone is that there's no exercise in that pre-exposure number. When you've been in a study for 3 or 6 hours and you've been exercising, then you may have some effect of the exercise alone versus the exercise plus ozone. So how do you control for that? The way you do it is you have a parallel exposure where it was filtered air, and you control for that exercise change. So, I mean, I think that's the way we always thought it out, but we tried to, when we analyzed the data, we'd look at it both ways.
Okay. Other comments on that?
I think they're two different questions, so I think I think they're both interesting, and I think they should be done both ways.
Okay.
Yeah.
Does anybody on the panel have questions for the author team?
Now's your chance, Mark. Get me back.
No, I think,
Well,
interesting.
Okay, so any of the policy gentle people have questions for anybody up here?
Someone at the-
Okay,
I'll just-
we're gonna go, we have a question from the audience, and then we have a question here, so. Elena Kraft from Environmental Defense, please.
Hi. So, one clarifying question is sort of on the,
Yeah, we can't hear you.
so just a clarifying question on the sort of objectives of this workshop. So the comments to EPA on their proposal were due several weeks ago. I guess what is the outcome in terms of materials or whatnot that, what's the plan, I guess, for any of the resulting conversations happening from this forum? Just a question. And then secondly, the air quality index was mentioned, and it seems to me like we're spending a lot of time, I don't know that we're ever going to get to the perfect number of what is going to be an adverse health outcome for the entire general population. What I do know is that when we tried to forecast exceedance days for ozone, we get it right about 50% of the time. So from the policy perspective, we don't have very good accuracy in terms of the warning system of letting folks know that it's a high ozone day. And so as close as we can get to figuring out the health side with a specific number, it seems that equal attention should be given to the modeling to understand when we reach those days. So those are just my two comments.
Sure, thank you. Dr. Honeycutt, would you like to talk about the plan for the workshop? Or maybe both ideas. I mean, go, please, feel free.
Good question. Is this working? Good question, Elena. Now, the proceedings from this won't be submitted to EPA. Of course, it's too late. But all the information that you've seen presented today has gone into the docket. So the information is there for EPA to look at. We're going to write proceedings from this and try to get them published. Who knows? They're hard. It's hard to get proceedings published these days. But this is information for anyone to use however they want to, consider however they want to, and plus we're looking ahead to the next round of the ozone next too. So that's that part.
Okay. All right, so I have a question from the audience, or maybe, was there a second question? Would you like to answer the second question?
Well, the second part was the AQI, right, and the utility of that. And I don't know, does anybody else want to take a stab at that?
What was the question about, specifically about the AQI?
So, in 2014, Texas had 14.
Thank you. So our web folks in here, we have a lot of people on the web here.
Thanks. So in 2014, State Environmental Agency highlighted 14 days where they had expected an ozone exceedance day. 7 of those actually turned out to be ozone exceedance days. Another 6 happened on days that had not been modeled by the agency to be ozone exceedance days. So my comment is that as close as we get to trying to define the actual number where we might see an adverse health outcome, if we're not setting up our alert system to be as good as our number, then in terms of protecting public health, we're not really reaching our goal because we're not getting the accuracy that we need on the modeling side. So in my mind, it warrants for additional consideration of being conservative on this standard because we're not getting what we think we're going to get in terms of the modeling data.
Okay, thank you.
Well, I think there's 2 different questions there. One is, where should the standard be? Okay, that's protective of health. And then the second question is modeling to that to warn the public that we might hit or exceed that number. And in my mind, they're 2 different things. We can always improve our modeling. There are things that we can do, but I don't think that really has to do with setting the standard and where the standard should be. That's more in the implementation phase. Am I missing something here, David? So, anybody else want to add to that?
Okay, I think we wore everybody out, but we're going to go with 2 more questions from either the web or the audience. These have come up before. They came up earlier today. Is the incidence of asthma, especially among children, still on the rise despite falling levels of ambient ozone over the last 20 years? And if so, what does that tell us about ozone's role as an agent for the incidence of asthma?
All right, I guess that's me. So asthma is, it's complex in terms of clinical diagnosis. So we diagnose asthma differently than we did when I started diagnosing asthma. And let me give you a couple of examples to show you how asthma could be increasing and really not have changed all that much. So cough, people who come into our office with persistent cough are often diagnosed as having asthma, like it or not. And there are reasons for it, which I won't pursue right now, but that's one. Medication is dispensed much more readily for people who have chest congestion, cough, what is called airways hyperreactivity, and the classification of asthma is sometimes based on the sales of asthma treatment drugs. So there are a whole lot of variables that go into the diagnosis of asthma. And certainly in some cities, in inner cities, there's been evidence of increased asthma in children. In others more recently, looks like asthma diagnoses may be down. Certainly if one saw ozone levels coming down and the diagnosis of asthma increasing, And it would be hard to say that the responsible or the causative agent was ozone. I just point out that it's not always that simple. The way physicians diagnose things change over time. And so one has to be careful in terms of knowing is asthma as it was classified or diagnosed 20 years ago the same as it is today. I would submit it's really a fair bit different, and there are many reasons for that. So one could still have asthma, the diagnosis going up and ozone going down for reasons that are unrelated. But overall, if asthma really is rising and ozone is going down, then the logical conclusion is that they're not related.
All right, Dr. Phalen?
It asks for some cross-sectional data. For example, we have high ozone in California, and perhaps there's lower ozone in Atlanta and Rochester and so on. So I haven't followed the literature, but a question would be is, does the Sun Belt have more asthma than the Rust Belt?
Great. This gentleperson has 3 other questions, one of which I'm going to mention, and then the other 2 we'll reserve for a different discussion tomorrow. What is the driving cause of the increased incidence of childhood asthma in the face of declining levels of ambient air pollution, which is related to what we just said? Any additional thought on that?
Well, I mean, there are lots of studies. I mean, there was a study in New York that linked it with, wasn't house dust mites, it was some other, was it mites? Yeah.
Right.
I mean, there are all kinds of explanations that we've talked about. They're not, it's not certainly a pollutant effect, but the diagnosis of asthma, I just urge people to be careful. It's we use somewhat different criteria today than we did 15, 20 years ago.
If I might.
I married a farmer's daughter, and she always claims it's the hygiene hypothesis.
Well, there you go.
They were exposed to all sorts of stuff, and she doesn't have any problems, and I have them all the time. I was just a clean city boy. Well, maybe not. All right, other comments from the audience? Yes.
Just one here. I want to take us back to the statute. First of all, thank you. This has been just tremendously useful. Let's go back to the statute just for a second. EPA is tasked with setting a standard that protects public health with an adequate margin of safety. What we've been talking about this afternoon, what you've been talking about this afternoon, primarily is what is an adverse effect on health? And what does the science show is there or is not there? What is science's role in determining, if any, what is their role in determining the adequate margin of safety? And how does what you provide inform the administrator's decision on that aspect of this problem? Because if the data says there's an effect here, well, how do you determine how far you have to go below that to find that adequate margin of safety?
Okay, good question.
I would leave that for the policy guys.
Okay, now, there might be some disagreement there. I mean, from the risk analyst's perspective, they would wade into that a little bit. But I think the easy way to wade into that is to say, what in the science gives us an idea of the uncertainty of the science? For instance, the numbers that we give you are fairly imprecise. Even the clinical controlled lab studies, the variability within a person every day, the resulting values you get out, they're certainly not good to 4 digits of precision. They might be good to like 2. And so there's some uncertainty there, and that uncertainty needs to be expressed to someone like the administrator. And maybe this table that Dr. Lange can share with all of us that talks about your different types of person and their ventilation rates and the different kinds of possible ozone standards will give you a sense of what? Human variability and just exposure parameters, which are an important aspect of choosing for coming up with a judgment of a number. And I'm gonna let my other colleagues that are risk analysts weigh in on this because I'm sure they do a better job than I did. Go
No,
ahead.
I completely agree, but I think it really is our job. We need to define what's adverse, and I think there are many regulations in this country based on homeostatic changes, biological changes that may be caused by a chemical or a substance, but they really aren't indicative, aren't on the pathway of an adverse effect or aren't adverse themselves. And so we need to define, and it's so difficult now with FEV1. I mean, is it 5%, is it 10%? But we need to just make a decision and explain the decision, justify it. And as Mike said, I totally agree too, and then talk about the uncertainty associated with it. I mean, what is it, 300 million people in this country? 320? All right, and we had 9 people with FEV1 decrements greater than 10%. At 60 in the Kim study and 72 in Schlegel. And I know we're gonna talk about all the other evidence later, but it's really these 9 people driving a regulation for 320 million. And so are we really certain that those 9 people represent this sensitive subgroup that the Clean Air Act mandates we protect? Or are they just possibly blips? And, are these studies even meant to really look at sensitive people, or really should we be looking at the mean? Because the mean is telling us if there's a difference and how big it is. So
Right.
I do think it's on us. I know it's a policy decision, but it hopefully is based on sound science.
Informed with some understanding of uncertainties. Did you two gentle people want to
Well, and
add or subtract from what you've heard?
I think EPA tries to present information in many different ways. One is, the health effects evidence that we're talking about now, which is, part of the equation. The second part, which I'll talk a little bit about tomorrow, is the risk assessment. I mean, and that is where they try to put together, the exposures and the health effects evidence to come up with risks and to come up with what those risks look like for alternative standards. And that's alternative standards are essentially lower standards. So, and there again, there is some interpretation that goes into how do you factor in the uncertainty in those numbers as well. And I'm not going to get ahead of myself and talk about it now, but that's one piece of it too that EPA brings into this discussion. So there's many different pieces, and unfortunately too, there's many interpretations sometimes of that,
Right.
of those pieces. So.
Okay, Dr. Lange? Anybody else? Okay, we have one last question from the audience. Go ahead, sir.
Howard Gilbert from Dallas. The recent NACWA decision involving the EPA NESHAP program talked a lot about taking variability into account in connection with the setting of NESHAPs. The court there was very impressed upon EPA the role that statistical analysis would play in the determination. Should I start over?
No,
We can hear you.
Okay, if you can hear me, then I'm assuming people on the web can't. I'm curious, from a scientific standpoint, scientific and mathematical standpoint, is there a statistical confidence level that ties back into what is an adequate margin of safety? This was not an attempt to stump the panel.
Well, okay, so we'll defer to the panel first. Any thoughts on that?
My thought is no. That it depends on the event, it depends on how serious the effect is, and it depends on how steep the dose response curve is. So if you have a serious effect with a steep dose response curve, you want to get a margin of safety pretty wide.
Right.
Yeah,
Yeah,
I think.
Go ahead.
Well, I was going to say 2 things. One is, the idea is when you take uncertainty and variability into account, you should have some sort of confidence interval. And if you want to be conservative and go, protect the tail of the confidence interval, I think that's one legitimate way to do it. But I think the other place that statistics plays a role, or that it should play a role, but I'm not really seeing it, is that, we are starting with a standard that we already have. I mean, a lot of this, I think Tim showed with his slides on the secondary standard. And I think the question really should be, is an alternative standard more health protective than the current standard? Because there's no question the current standard is public health protective. And if there's no statistical difference, then you really don't have justification for lowering the standard.
And EPA doesn't do those statistics that you need to answer that question.
That was really my question, is whether there's statistical precedent for how to approach this.
Let me just add a little bit that's more biological. Because I'm not afraid of statistics, but I'm not very good at them either. Oh, did I say statistics? You did. It's late in the day. The biological thing is you go down in dose or concentration. Dr. Phalen has actually said it. The severity of the impact goes down. You go from adverse effects, clearly clinically adverse effects, no question about it, down to moderately adverse, reversible effects, but still adverse, down to compensatory findings that are not adverse. You walk up the steps here, and you will start to breathe hard. That's compensation, because you build up lactic acid in your blood because I'm out of shape. It doesn't take me even 4 flights of stairs. And your body compensates by exhaling carbon dioxide to get your acid balance back. That's not adverse, even though it's an effect. Then you have homeostasis and adaptive and all those kinds of things that are effects. And then you get down to physiological effects that you can get just by drinking water. And all those things are they're not adverse, much less, and they're certainly not in the severity scale. So if you go down in severity to the effect, that has a lot to say about margin of safety or margin of exposure. Is it a margin of exposure from mortality? Well, it better be pretty big. If it's margin of exposure from enzyme changes or maybe saturating your metabolic ability to detoxify in the lung, margin doesn't have to be near as big. I mean, it can be a judgment like that. Okay, so that was really the last question, but we have one last, and then we're going to let everybody go because it's been late. Go ahead, sir.
I was just gonna say, I'll try to speak loudly.
Microphone, they can't hear you on the web. Sorry.
Tim French with EMA. On this last point about margin of safety, doesn't your work, Dr. Lange, show that we already have quite a broad margin of safety? If you actually look at the threshold effects or the threshold for FEV1 effects, even at the current standard of 75, looking at activity patterns and how people live their lives day to day, we're already dealing with a huge, I would submit, margin of safety, aren't we, from an actual, if you're looking at it from an FEV1 effect?
Yes, those graphs do show that there is quite a margin, if you, between the lowest threshold, the 5%, even the 5% FEV1 threshold, and for the most part, the actual exposures that we would expect from this type of diary data.
And that's why I think what you've shown about all the components of dose, which really kind of get lost in the laundry through all the 3-foot document that you have to try to wade through with EPA. It's really sheds a lot of light on what we're really talking about, and really does point out that is there a change that's necessary at this point to protect public health?
Okay. Well, listen, I really appreciate the fact that you stood the test of time, so we're going to turn this